All right, welcome to The Explainer. Today, we're going to talk about a tool that works pretty much non-stop behind the scenes in the software world. You might not have heard of it, but it's an absolute game changer. We're talking about Jenkins, the open-source automation engine that completely changed how software gets made. So let's get right into it. So, you know when you tap Update on your phone, and just like that one annoying bug is finally gone? Or, hey, there's a cool new feature. It kind of feels like magic, doesn't it? Well, it's not. It's actually a super refined, automated process. And you know, a lot of the time there's a tool like Jenkins acting as the wizard behind the curtain, making all of that happen.
And to really get why this is so important, we've got to take a little trip back in time. See, not too long ago, releasing software was, well, it was a nightmare. It was slow, totally manual, and super risky. You'd have developers working for months, then they'd try to merge all their code at once, and basically just cross their fingers and hope for the best. Now, it's the total opposite. Fast, automated, reliable. It's all designed to catch problems right away and get new stuff out to you constantly. And yeah, this huge shift, it definitely didn't happen by accident.
It was all part of a huge revolution in software development. A better way to build things, called CICD. Now that stands for Continuous Integration and Continuous Delivery or Deployment. And it's not just a tool, it's a whole philosophy, a practice that really did transform the entire industry.
Okay, let's break that down. First up, CI, or Continuous Integration. So what does that actually mean? Well, think of it like this. Developers are constantly, and I mean constantly, merging their new code into one shared central place. And every single time they do that, an automatic build kicks off, followed by a whole bunch of tests. Because of this continuous cycle, you find and fix problems almost instantly, instead of, weeks or even months later when it's a huge mess.
All right, so that's CI. The other half of this puzzle is CD, which can mean a couple of things. Continuous delivery or continuous deployment. Once a chunk of code gets integrated and passes all those tests we just talked about, CD takes over. It automatically packages everything up and gets it ready to go. Now, continuous delivery means it's ready for a human to push the button to release it. But continuous deployment? That goes even further. It can push that update live straight to users with no human intervention at all.
Okay, so CI/CD sounds great, right? But how does it all happen? What's making it work? Well, this is where our main character, Jenkins, finally enters the story. I love this analogy. Think of Jenkins as the loyal, tireless butler of the software world. It's the one managing this whole complicated process, from the very beginning to the very end.
And Jenkins isn't some new kid on the block. It's been around for a while. Its story actually starts back in 2004 at Sun Microsystems, but it was called Hudson back then. Then, when Oracle bought Sun, there was some, let's call it, drama. And the community decided to fork the project to make sure it stayed open source and free for everyone. They renamed it Jenkins in 2011, and, well, the rest is history. Today, it's an absolute powerhouse and pretty much the go-to choice for teams that need to automate their work. So, to really wrap our heads around what Jenkins does, let's do something fun. Let's follow one single piece of code on its incredible automated journey. In the biz, we call this a pipeline. It's just a series of automated steps that takes that code from a developer's keyboard all the way to you, the end user.
And a typical pipeline, the kind Jenkins manages, usually has 4 main stages. It all starts with a commit. Then it moves to build, then test, and finally, if everything looks good, deploy. In Jenkins, it's like the conductor of an orchestra, making sure every single step happens in the right order at the right time.
Okay, step 1. The journey kicks off right here. A developer makes a change, let's say they fix a bug or add a cool button, and they commit that new code to a shared place, something like Git. That one action, that commit, is the trigger. It's the starting gun. Jenkins is always listening, and the second it sees that new code, boom, it springs into action and the pipeline starts rolling.
Next up, we have the build stage. Jenkins grabs that new code and it builds it or compiles it. This is the part where it turns all those lines of text a human wrote into an actual working piece of software that a computer can run. And this is a critical checkpoint. If something's wrong and the code can't even be built, the pipeline stops right there, and it immediately tells the developer, hey, something's broken.
All right, so if the build works, we move on to what is maybe the most important step, testing. This isn't manual testing. Jenkins runs a whole ton of automated tests. It's looking for two things. First, are there any new bugs in the new code? And second, and this is just as important, did this new code accidentally break something that was already working? It's the ultimate quality control checkpoint.
And at last, the final stop, deployment. If and only if the code passes every single one of those tests, Jenkins takes that final step. It automatically pushes the new version of the app to a server, which makes it live and available for everyone to use. And get this whole journey, from the developer's commit to being live, it can all happen in just a few minutes. It's incredible.
So okay, we've seen what Jenkins does, but the big question is why? Why is it so popular? What's the secret sauce that's made it last so long in an industry that changes like every 5 minutes?
Well, let's start with a really big one. Time. Just straight up efficiency. By automating all of this boring, repetitive stuff, Jenkins lets developers get back to doing what they actually love and what they're paid to do, building cool new things. And we're not talking about a small improvement here. We're talking about cutting down the time developers waste on this stuff by 20, even 30%. That's huge.
Its power really comes down to a few core things. Its superpowers, if you will. First off, it's open source and totally free. You can't beat that. But its real magic might be its massive ecosystem of plugins. There are thousands of them. Seriously? You need to connect Jenkins to pretty much any other tool on the planet? I bet there's a plugin for that. Plus, it's built to scale up for massive projects, and it lets you define that whole pipeline we talked about as a simple text file. And that scalability we just mentioned? It comes from a really clever design. Jenkins uses what has traditionally been called a master-slave architecture. Now, you'll often hear more modern terms these days, like controller and agent, but the idea is the same, and it's simple and powerful. You have one master Jenkins instance that acts as the boss. It organizes everything and tells everyone what to do. And then you have multiple slave machines, which are the workers, that do all the heavy lifting, the actual building, the testing, and so on. This lets you spread out even the biggest jobs across a whole fleet of computers.
And this right here might be the most revolutionary feature of all. It's called pipeline as code. That entire journey we just followed, commit, build, test, deploy, every single step can be written down in a simple text file. It's called a Jenkins file. Just think about that for a second. It means your automation process is now code itself. You can save it, you can track changes to it, you can share it and review it, just like you would with the application's code. It's a total game changer.
Okay, so let's tie this all together. What are the big takeaways here? First, Jenkins is the engine that drives modern software automation, that whole CICD thing. It automates the pipeline from the second a developer writes code to the moment it gets to you. And because of that, teams can find bugs way faster and get new features out the door more quickly and reliably. Its real power comes from that killer combo of being free, having all those plugins, being able to scale, and that pipeline as code idea. And the bottom line? It saves a ton of time and, just as importantly, cuts down on simple human error.
And that really brings us to a final, bigger thought. Jenkins proved to the world that you could take this incredibly complex, super-critical process, building software, and automate it. It showed that something that used to be slow, manual, and full of errors could become fast, reliable, and almost completely hands-off. So it kind of makes you wonder, right? If you can successfully automate the entire journey of a piece of code, what's the next big, complex journey that's waiting to be automated? Something to think about. Thanks for tuning in.